Last month, global attention locked onto the interstellar comet 3I/Atlas as it passed safely near our planet. Yet, few spotted the genuine peril lurking nearby. A colossal space object, 100 times the size, C/2025 R2, entered the solar system without detection, masked by the sun's intense radiance. Detection came only post its nearest solar pass via a satellite hydrogen detector. Ground observatories missed the chance to issue warnings. In a mere 7 days, this behemoth will approach Earth nearer than any prominent comet in recent history. The risk isn't some cinematic collision. It's our oversight, plus how scattered debris and unseen gaps might spark unforeseen fallout. Why did it evade us? And are preparations in place for the sequel? On September 11th, 2025, a subtle UV shimmer drew Vladimir Bizigly's eye. He reviewed readings from the Solar Wind Anisotropies SWAN tool on SOHO, the satellite that's monitored the sun's fringes for almost 30 years. The snapshot revealed a hydrogen halo bloating in an unforeseen path. Soon after, the SWAN crew marked it as a potential comet. Earth telescopes rushed to verify, yet the entity stayed shrouded in solar brightness, undetectable by any ground optical scans. Solely SOHO's UV sensors, tuned to hydrogen flows from frozen cores, unveiled its presence. When the alert propagated via formal routes, the comet had surpassed its solar minimum. Bizigly's spotting earned the label C/2025 R2 SWAN, the 20th comet attributed to this veteran orbital sentinel. Its hydrogen sheath spanned millions of kilometers, indicating fierce vapor release and swift luminosity increase. To stargazers, this marked a win for tenacity alongside a stark exposure of weakness. Absent SWAN's UV capability, the comet would have evaded notice until well beyond perihelion. Many terrestrial scopes fixated on misguided sky sectors, overwhelmed by solar dazzle. The breakthrough stemmed not from a lone watcher or device, but from a network designed to nab what surface sites overlook. The pressing query shifted from SWAN's role to how many similar titans lurk in the brilliance. Solar luminosity etches a no-see zone that's plagued sky watchers for more than 100 years. Dubbed the Holochek effect, this swath spans about 30 degrees around the sun, a domain where surface telescopes falter in hunting comets or asteroids. In such periods, cutting-edge optical hunts prove futile. Dusk dilutes dim targets. Air diffusion renders the heavens murky, and our planet's path geometry keeps sunbound intruders veiled until they veer from the solar face. From late August through mid-September 2025, C/2025 R2 traversed this unseen passage. Viewed from here, the comet nestled in broad daylight. Its quick glow-up fully concealed by the sun's dominant blaze. The Holochek void isn't a tech flaw. It's a core barrier from physics and layout. Even vast, luminous bodies can glide past unnoticed if timed poorly. Orbital tools like SOHO SWAN Imager stand as key outliers. By tracking UV signals from hydrogen, they detect comets in zones inaccessible to earthly vision. Yet SWAN's scan range narrows, and its worn sensors yield merely a fragmented view of hazard areas. The truth hits hard. For almost a month, this long-period wanderer hurtled into the solar core. Its gas bursts and dust blasts went unseen by all primary Earth surveys. The Holochek barrier doesn't merely obscure the remote and subtle, it can veil behemoths until they've joined our midst. Every item lost to solar dazzle underscores our cosmic vigil's dark patches, where alerts might arrive only post-threat. On September 12, 2025, C/2025 R2 hit perihelion, its sun-nearest mark, arcing in at 0.503 astronomical units, roughly 75 million kilometers, from the stellar blaze. This marks the pivotal instant long-period comet's fear and experts await. The shift when eons of icy dormancy yield to a solar power flood, reshaping a subdued Voyager into a display or victim. At such proximity, solar rays intensify fourfold versus Earth's, pushing nucleus surface heats beyond water's melt threshold. Ancient ice strata, pristine since antiquity, start sublimating fiercely. This brews a high-pressure frenzy, with gas dust plumes bursting from fissures and flaws, fueling the growing coma and tail. Heat strain at perihelion might fracture veteran comets, particularly those re-emerging from millennia in the void. For C/2025 R2, the perihelion transit served as catalyst and trial. The comet's hydrogen envelope, the comet's coma, expanded dramatically, indicating a surge in water output as solar UV radiation dissociated molecules escaping from its surface. Those monitoring the phenomenon observed the coma's swift enlargement, though the central nucleus stayed concealed. There was no discernible central structure, merely a luminous, indistinct spot amid the commotion. Due to the sun's intense brightness obscuring clear views, any abrupt eruption or breakup would remain undetected until the comet ventured into dimmer regions of the sky. Reaching perihelion represents more than a mere point on its trajectory. It serves as a severe test that decides if a comet endures whole, releases pieces, or breaks apart completely. For C/2025 R2, the occurrences during those sunlit hours would influence all the erratic actions that ensued, including surges, dust streams, and the chance of fragments dispersing along its route. The true narrative of this cosmic guest's instability commenced as it traversed the perihelion threshold. C/2025 R2 will sweep by Earth at a distance of just 0.2606 astronomical units on October 20th, 2025, around 39 million kilometers, equivalent to approximately 101 times the Moon's separation. For an object of this magnitude and luminosity, such nearness isn't ordinary. It qualifies as a rare occurrence, happening once every few centuries rather than decades. Yet closeness by itself doesn't reveal the full picture. The minimum orbit intersection distance, or MOID, quantifies the tiniest separation between Earth's path and the comet's orbit. For SWAN, this MOID stands at 0.048 astronomical units, roughly 7.2 million kilometers. On a universal scale, that's a close shave. It falls squarely within the threshold that alerts planetary protection specialists to possibly threatening bodies, despite the collision probability being nil in this instance. These figures require perspective. Mars approaches to about 56 million kilometers from Earth at its nearest. SWAN's passage cuts even closer, navigating the space between our world and the paths of our closest planetary companions. By contrast, the highly anticipated interstellar visitor 2I/Borisov never drew nearer than 1.8 astronomical units, or over 270 million kilometers. SWAN's trajectory brings it more than six-fold closer, and all in the same week. The countdown doesn't concern collision threats. Rather, it focuses on the insights to gain and the details that could slip away in these brief days of minimal separation. With the comet's course fixed, the pressing need arises from its conduct. Surges, ejections, and the risk of hidden fragments grow ever more vital as the gap narrows. The MOID transcends a mere figure on graphs. It marks the boundary separating a benign encounter from a trail of debris that might traverse Earth's vicinity. Each kilometer counts. As October 20th nears, stargazers hurry to gather all feasible observations. The opportunity for detailed imaging, monitoring abrupt luminosity shifts, and charting the particulate surroundings is fleeting. After SWAN pulls away, scrutinizing a long-period comet from such proximity won't recur anytime soon. Time presses on, with the value hinging on the data secured before the peak slips by. In late September, an unforeseen escalation defied all simulations. The luminosity of Comet C/2025 R2, which had been fading gradually post-perihelion, abruptly increased by over 1 magnitude in under 12 hours. Viewers in the southern skies recorded the rise initially. A previously subtle blur in broad surveys now matched the faintest stars detectable without aid. The coma's broad expanse acquired a striking emerald hue, characteristic of C2 and CN compounds glowing under solar UV. This tint, well known among comet enthusiasts, indicated vigorous chemical reactions, an outburst as concealed ices sublimated and expanded outward. Streams of particles and vapors started to spread from the center, etching temporary curves and lines through the coma. The arrangement of these streams altered from hour to hour, suggesting a rotating or perhaps erratic nucleus hidden under the veil. Nevertheless, no ground-based scope, regardless of size, managed to distinguish the nucleus. It persisted as a tiny veiled by the radiance of its emissions. Efforts to spot any splinter, secondary piece, or attendant body yielded nothing. Should the September flare have fissured the nucleus, proof lay entombed in the haze, undetectable save by the finest detectors. The comet's variability reached its light variation profile. Predictions placing Swan at magnitude 6 by October got surpassed by events. It fluctuated between magnitude 6 and 7 with sharp nightly variations. Hobbyists pondered if these were new ejections or merely illumination effects on expelled material. In truth, certainty eluded everyone. Ancient dynamically comets, such as this, bear marks from prior solar brushes, cracks, exhausted layers, volatile ice enclaves, poised to burst at opportune times. Each flare altered expectations, and every luminosity peak evoked the threat of breakup. The verdant coma, the wayward streams, the indistinct nucleus, all signify an entity in constant change. Its subsequent actions it's nearly impossible to get a firm grasp on. For anyone monitoring possible dangers, this situation is a worst-case dream. A massive, lively comet nearing Earth, marked by erratic bursts and lacking any evident stability in its core. The sole dependable factor is the unpredictability itself. And as fresh photos emerge, the inquiry intensifies. What secrets, if any, lurk within that haze of particles and glow? The trajectory of C/2025 R2 evokes a stellar cautionary sign. Its route extends to the brink, boasting an eccentricity close to 0.999, a cycle exceeding 22,000 years, and a tilt of merely 4.5 degrees relative to Earth's orbital path. Such positioning feels far from coincidental. Typically, extended-period comets plunge in at sharp inclines, lingering near the ecliptic for mere hours or days before retreating into the void. In contrast, Swan dwells in Earth's pathway for several weeks, traversing the very cosmic route shared by planets and orbiting probes. The chances of a colossal, dynamic object navigating this narrow passage are exceedingly low. Yet the implications extend well past mere probabilities. Each flare-up, each gas ejection functions as a tiny propellant against the nucleus. The science is unforgiving. Solar rays batter the exterior, frozen materials sublimate, and streams burst forth, diverting both debris and the central body from anticipated courses. For an entity as vigorous as this comet, those non-gravitational influences aren't mere addendums, they're unpredictable elements. Post-perihelion, positional measurements reveal a deviation of roughly 1,000 km from the forecasted line, a clear mark of the propulsion from venting. Smaller pieces experience this even more intensely. Solar radiation and atmospheric pull can hurl debris from millimeters to meters across altered routes, generating a scattered trail that elongates parallel to and beyond the comet's line. These bits persist. Across days and weeks, they whirl outward, crafting an expansive band of fine particles and tiny shards. Earth's yearly path intersects this zone routinely. However, in 2025, the timing feels perilously aligned. Even a thinned-out flow laden with invisible specks can elevate the meteoroid influx significantly. For satellites circling low Earth, additional strikes per square meter might erode photovoltaic arrays, scar instruments, or, in uncommon instances, trigger total breakdowns. The danger steers clear of cinematic collisions. Instead, it's the quiet, probabilistic menace of heightened micrometeoroid activity, undetectable until equipment falters. Past examples illustrate how swiftly the space around us can shift. Comet 73P/Vassman-Vakman 3 fragmented near Earth, and its scattered remnants bombarded our planet with shooting stars for years afterward. Swan remains intact, for now at least. Yet its irregular emissions and obscured core leave fragmentation as a viable concern. Every fresh stream, every unexplained deviation underscores that comet dynamics transcend orbital mechanics. They encompass each splinter, each dust mote, and every craft ensnared in the fallout. The pressing issue now transcends the nucleus's destination. It's about where the ejecta will settle and our preparedness to detect it. October 2025 brings a heavens so bustling that even veteran skywatchers struggle to sort their focuses. Comet C 2025 R2 isn't the sole comet dominating the observations. C 2025 ACE, more familiar as Lemon, is gaining luminosity, offering a viewable spectacle through binoculars right as Swan reaches its nearest point. Meanwhile, the Orionid meteor display crests on October 21st evening, scattering remnants of HALs across the early morning firmament. To the general audience, it's a stellar extravaganza. Dual comets gracing the view in 1 week, shooting stars arcing above, media buzzing with exaggerated praise. But for experts handling genuine threats, this overlap cuts both ways. The dazzle pulls gazes skyward, yet it fragments focus. Public education efforts emphasize spotting tips and imaging advice, relegating quieter perils, like particle trails, peace wanderings, orbital craft vulnerabilities, to the sidelines. Amid a calendar crammed with astronomical draws, the real test lies not in spotting the wonders, but in discerning which dangers warrant constant watch and which prove mere diversions. The formal announcement of C/2025 R2 sparked the usual protocol sequence. Minor Planet Center, JPL Horizons, then CEO. Every phase in this process builds on prior inputs, and each segment carries its own hurdles. The Minor Planet Center gathers early positional data, often inside 24 hours of validation. For comets akin to Swan, though, that input begins sparse. Only a few sightings post-Swan, all following perihelion with the core still indistinct. Horizons generates initial path calculations, but limited viewing spans inflate the unknowns. As of October 13th, path models rely on barely 3 weeks of data, and factors like non-gravitational pulse, emissions, streams, minor shifts can skew the projected route by thousands of kilometers. CEOs, the final hub for hazard evaluation, won't initiate records without indicators of genuine peril. For extended-period comets, the approach stays minimal. This creates voids in immediate notifications and threat simulations, particularly when sudden flares or abrupt increases in luminosity demand hands-on scrutiny. Every revision to orbital paths calls for personal supervision, not merely to ensure precision, but to uncover the unforeseen. As tools such as SOHO's LASCO undergo deterioration and their adjustments shift over time, the entire process risks collapsing at a critical juncture. A single sensor, now decades in service, keeps vigil on the solar disk's hidden flank. The framework appears sturdy in theory, yet real-world events like the late detection of Swan expose the heavy reliance on chance, precise moments, and a limited team of fatigued observers. Tiny space rocks often evade the safeguards. Back in 2008, TC3 was identified a mere 19 hours prior to its disintegration above Sudan. Half a decade on, in 2014, AA plunged into Earth's upper layers with virtually no advance notice. Similarly, during 2019, asteroid MO was picked up only a few hours ahead of its detonation off the coast of Puerto Rico. The takeaway is straightforward. The trajectory's direction combined with solar glare can wipe out days or even weeks of forewarning, regardless of the sophistication of the tracking efforts. Cometary bodies introduce yet more elements of chaos. During 1990, 73P/Schwarzmann-Watchman 3 fragmented on a near pass, dispersing debris and particles that dotted our planet's atmosphere for an extended period. These incidents all highlight a core weakness. Items spotted at the last minute or shattering without warning afford scant opportunity for countermeasures. The priorities are now evident. Refine trajectory forecasts each day with incoming observations. Advocate for detailed imagery to identify shards promptly. Harmonize broadscope surveillance for particulate trails and meteor flows. Exchange live records from satellite collisions and radar detections of shooting stars. Prioritize development of outward-looking solar observatories beyond terrestrial scans alone. Most importantly, develop accessible interfaces that highlight dangers openly rather than just the visual wonders. Every delayed sighting serves as a wake-up call. Constant alertness stands as the sole safeguard amid such expansive gaps in our celestial view. On September 11th, 2025, Comet C/2025 R2 dubbed SWAN, emerged into view only 1 day prior to its nearest solar encounter, slipping past terrestrial detectors owing to the Holzberg obscured region. In contrast to the much-talked-about C/2019 Y4 Atlas, SWAN is set to skim within 2,606 astronomical units, roughly 39 million kilometers, from Earth on October 20, 2025. Historical records verify no immediate collision hazard, though the belated identification and erratic activity emphasize a fundamental gap in our surveillance chain. Precedents such as 2008 TC3 and 2014 AA illustrate how perilous items can surface with minimal alert, while the disintegration of 73P underscores the dangers of breakup events. In the present day, the genuine peril lies not in the comet per se, but in the boundaries of our watch systems, particularly for inbound solar visitors. With cosmic traffic intensifying, regular refreshes, focused scrutiny, and funding for solar-oriented instruments emerge as pressing imperatives. The narrative surrounding C/2025 R2 SWAN underscores that the following unforeseen event could already be inbound, concealed within the solar brightness, poised for revelation.